So this problem, hopefully you were able to put this data into your calculator and you were able to get the information that we need from it. We said it was 2 times 10 to the negative fourth. That's, oh, it's tiny over there. I'm not used to it being so skinny. Wrong way. Having 3 screens is great and weird. Because, like, yeah, but that was the same as that one. All right, so here we go. This was the other data. Hopefully we're fine with these. Once again, you were all able to get 0.056 correct after some manipulation. Now, so all that math was for a first order. And here's the good news. What we've just been doing, it will tell us if it's not a first order, and there's a way to see if it's second order. And do you remember what first order and second order meant? What the power was. All right. Oh. That should be on.
It's a nice mouse.
That is a good looking mouse. Thank you. It is recording. Unfortunately, I can't change which camera it is. So it will stay my mouse the entire time. But we'll be all right. Uh-oh. We'll just go full screen and get rid of that. But thank you. Okay. So, yeah, it's hidden right now. Creepy. But yeah, I should have selected that camera before we moved on, but we'll be fine. All right, so the good news is second order reactions are a little bit different, but they're a lot the same. And what I was about to say was what we have is we know the rate equals K, and now we have a way for first order, and we will teach you a way for second order how to find K. And then for each part, we would be able to also know if this was a 1 or if it was a 2 based on whether, if it's first order, the plot of the ln versus time. If that's linear, first order. If it's not, we'll do another test, and if it's linear, then it will be second. So really, we can use this to pretty much find, right. We'll be able to use this to find the entire rate law, and then once we know the rate law, we can do other calculations from that. You okay with that? All right, so a second order reaction has some different math. I guess I kind of skipped over there. When we take the integrated rate law for it, we end up with 1 over AT equals negative KT plus 1 over A naught. Now, you may want to chop what these parts mean up again. So AT, that means the concentration at a specific time. This means concentration when? At the start. All right. K is just your value, your rate constant, and T is the specific time we're talking about. Second order for ln versus time, they are curved. But we're not going to, we have a different plot that will actually be linear. Because there are more than first and second order reactions. It could be a third or it could be a 0. So we'll see if it's not first order. So if your first graph is curved, type your second one in, and if it's curved, then it's most likely a 0, to be honest with you. Because we don't usually do thirds, because those are very complicated math. All right, this thing is also in the form of y equals mx plus b, where this thing, this would be your y, mx, and this is your b. All right, so it can form a line also. So if a process is second order in A, A plot of 1 over a versus t will yield a straight line, and the slope of that line is k. So we had one of these yesterday. I said, you need to commit this to memory. This is another thing that today you need to commit to your memory. All right. So any guesses what we're going to do next? All right, we're going to take L4. And we're going to set L4 equal to what? One over the concentration was L2, right? It just depends on you. So I would always put both in. That probably is a waste of 10 seconds because if your first one was linear, you didn't need the next one. But when I was in that stat area, I just always did it because it didn't take me more than 10 seconds to put a fourth list in. Because then if ln isn't one, then you got to go back in and see if the other one is. All right, now I'll give you a new data sheet because the data we have, we already know that's first order. So that's not going to help us. So here we go. All that stuff at the top, yada, yada, yada. Who really cares? So here we go. Here is your time data. Here is your concentration data. There's your ln. And there's your 1 over. Now, if you have the old calculators, remember you'll have to keep the L2 will have to change depending on which graph. Once again, raise your hands if you have the old version of calculator. Okay. So the workaround, it's not that bad, but the workaround is that this will be L1, L2, L3, L4. For the workaround, always put this data in L3. Okay? Don't make L4. Like you can, but you don't need to. Because the first thing you're going to do is then make this equal to ln of a. And if it's linear, you're done. If it's not, you're going to go back in and change this function to 1 over a. And then if it's linear, that will tell you that that's second order. So you just keep changing this column until you get a straight line. Brunner, maybe? Ben? Would? Kind of makes sense? Okay. If your calculator has been updated recently, you don't need to do that because it will always do the linear regression of what you plotted, which would be nice if they always did that, but they don't. All right, when you got this one, you should have noticed it looked like that, right? So it has a positive line, so the k will be equal to the slope. We don't need the negative sign to make it a positive value this time. You okay with that? All right, and now you could know the rate law. Rate equals k. What was the value? 0.54? 0.54 times the concentration of NO2 squared. Where'd the 2 come from? The 2 came from the fact that it's second order, because this one looked like that. Or so, I don't know. It was curved. That was your first order. I did this last year. My kid's like, hey, that's a Chinese symbol, by the way. I remember this moment in my life. This right here. I don't remember. But I remember he's like, that's Chinese. I'm like, no, it's not. But my kids think it is. All right, sorry. Whatever. That 2 comes because this line was linear, which means it's a second order reaction. Yeah. I am blown away. We were watching a soccer game the other day, and they had Chinese on their shirt, and my third grader, I don't remember what it was, but it was some name he could read. I was like, you can't even read English yet. Okay, this is all this stuff. This is the same problem. All right. The value. We'll do another practice one right after we talk about this. But the value of this process comes here. Once you've determined the order of the reaction and the K value, you can use the integrated rate laws to solve for concentrations at specific times. That's what this one's really for. We have your T's right here. These are your time values. It's nice for a chemical engineer or any type of chemist to know what your concentrations will be at specific times. It's really important. We know that based on a rate law and then the math from the integrated rate law. Now, these are not super easy to solve for T. There's some algebra there, right? But they're doable. Okay, here we go. Well, obviously it's probably going to end up to be a second order reaction. But I know it's blurry. This is from an actual AP test. So here we go. Here's your data. That's your time. There's your concentrations. Spoiler alert, I'm guessing it's probably a second order reaction. We're going to determine the rate law. I'm sorry, this is so blurry. Write the integrated rate law. Determine the value of the rate constant. And then calculate the concentration of NO2 at 2.4 times 10 to the 4 seconds. If I try and shrink this and make it clearer. It's still blurry no matter what I do. I know. Oh, I lost the data. There we go. Like, it's probably clearer to you. It's super blurry when you're close to it. Now, you don't have to make all three because you know it's second, but I would practice doing the whole process, pretending you don't know which one it is. All right, we'll pick the straighter of the two of them then. I can scroll back up. All right, I'm going to scroll back. Okay. So the way you would do this is just set your calculators up. When you graph, the one that is most linear was intended to be your second order, right? And then you just find the slope of that. So if it's second order, then the rate law will be equal to rate equals K. It's the same thing as we had in the last problem, right? NO2 squared. Okay, so that's just the rate law. You don't have to put any numbers in. So we use this process just to find that exponent. All right? Then we also use this process. We use this process to determine which of the integrated rate laws we will use, which is the second order integrated rate law. Now you don't have to memorize that. That equation is given to you on my test and on the AP test. All right? Determine the rate constant. So the rate constant just came from the rise over run, or the slope here. And I don't know, what did we have? 2,400? Is that not it? Oh, 2 times 10 to the negative 4. Everyone agree with that? Okay, so sorry. So that is your rate constant. Whoops, right here, sorry. Is that right with that? Does it ask for the units? No, so you don't have to give it. Next, calculate the rate law we did. Calculate the concentration of NO2 at 2.4 times 10 to the fourth. Okay, so we're solving for this value right here. Correct? All right. I don't know. I don't have like time to do every second or every part of the algebra, but we're going to take, now I'm not crossing that out, I'm just calling it x. So we're going to take x over, oh crap. We multiply both sides by x, right? You okay with that? But then we've got to take this all under. You with me? So the concentration of A at times T is equal to 1 over all that, KT plus 1 over A naught. All right? And all these things are given to us for our good. Okay, never mind. So our concentration at AT is equal to 1 divided by K, which was 0.0002 times T, which is 24,000, isn't it? Yeah. All right, plus 1 over, what was it? 1 over 0.5 or 1 over 2? Okay. The point, that's the initial concentration. A naught is this value right here. All right. Then do this math and add 0.5. Does anyone have the answer to what the denominator is? Does anyone know that number? Well, what's
7.1. That sounds familiar.
then? So it's 1/7, and you're done.
Yeah.
0.142. Who had that answer? Raise your hands. 1, 2, 3, 4. You're really close.